Welcome. This question says, what is the pressure created when a 50 kilogram person balances on a 4 millimeter by 4 millimeter heel, a square heel? Let's visualize. Here's the person, and they are balancing as best they can, and let's show their foot like that, and it's this area here. So if you imagine they have a kind of stiletto heel like that, and this area here at the bottom of the stiletto heel, here's the foot, and here's the ankle, here's the round of the toe. So in this stiletto heel area, this is 4 millimeters by 4 millimeters. So what's the pressure underneath this heel? And we say pressure is equal to the force per unit area, or the force divided by the area. So we have the force, and the force is of course equal to the mass of the person times g over the area, which is going to be, in this case, 80 kilograms times 10 newtons for every kilogram, that's g, over 4 times 10 to the minus 3 times 4 times 10 to the minus 3. So pressure is equal to 800 over 4 4s are 16, 16 times 10 to the minus 6. So that would equal 50 times 10 to the 6. 16 goes into 800 50 times, and the 10 to the minus 6 on the bottom becomes 10 to the 6 on the top, which is Pascal, which is going to be equal to 50 megapascal. So that would be my answer. It raises a bit of a question, and that is, what's the difference between 4 millimeter square and 4 square millimeters? They're not the same animal. What we just did was 4 millimeters square. We did 4 by 4. We gave you the 2 dimensions. If we said 4 square millimeters, it's a square millimeter 4 times. So there's quite a bit of a difference. This is 4 by 1 in terms of its dimensions. If I had 4 by 4, I would not have the same area. 4 square millimeters is 1/4 of 4 millimeters square. So you've got to be a little bit careful about terminology. Most people will try and be very clear about which they mean. In here, to avoid ambiguity, I said 4 millimeters by 4 millimeters. But just be careful about that. Try to visualize. Visualization is the key most of the time. So there we have it.